Okay, so now that we've talked about motion diagrams, let's start using motion diagrams and vectors to start understanding motion itself. So I'm going to draw a very simple motion diagram. This is just for an object that's undergoing constant motion. You can see right here, each one of these time intervals, it's going the exact same distance. So it's not speeding up or slowing down, it's just moving at a constant speed. Um, and I'm going to pull out of this vector. We're going to call this one this time 0, time 1, and time 2. And we're going to look specifically at those two, or at those three intervals. So it starts here, and from time 0 to time 1. So over our first second, it goes to here. So we can call this is our first displacement vector. We'll call that x1 because the displacement is from here to there. Our second displacement vector looks like this. This is x2 because it takes us from our initial position all the way out to our next position. If we want to figure out how to go from x1 plus something is taking us to x2, we can draw in the vector because we can recognize that if this is the resultant and this is how we started, then what vector added to this one will get us to this one? And the answer to that is fairly simple. It would just be this vector here. This is our unknown vector that takes us from here to here. So I'm gonna do some fancy math stuff real fast. And one of the things that I'm gonna do in here is I'm gonna put time in there because this was a vector that took place over a specific time interval. That this was the vector that took place over time 1 to time 2. So that t there just represents time. And if we play around with the math a little bit, play around with this equation that I have, we could subtract x1 from both sides. So minus x1 from that side, minus x1 from this side. It cancels there, ends up there, and then we would get something t equals x2 minus x1, those two vectors. And then if we divide both sides by t, divide this side by t, divide that side by t, we get something is equal to x2 minus x1 over time. And so now we can start actually defining what that question mark is. This question mark, whatever this vector is, represents the change in, oops, that should be a 1, the change in position over time. And that is a new quantity called the velocity. Velocity is defined as the change in position over the change in time, and we use v. But since it's actually a vector quantity, we can put an arrow above it to say it's not just a change in position, but it's a specific change in position in a specific direction. So there's our velocity vector. And that means we can now go back to our motion diagram and start pulling out some information. We can say that each one of these arrows isn't just an arrow, it's actually specifically a velocity. This is a velocity that is 3 units over 1 unit of time. 3 units over 1 unit in time. 3 units over 1 in time. 3 over 1, 3 over 1. So, I mean, the math works out that each one of these is 3, and if we were talking about something like meters and seconds, each one would be going 3 meters per second. We can go one more step with this though, because if we compare, if we try this with a slightly different drawing, let's start from 4, 3, 2, 1. So I have a vector going from there to there, there to there, there to there, and then just a little bitty one. We know that our velocity 1 vector is 4, let's call it meters per second. Our velocity 2 vector is 3 meters per second. Our velocity 3 vector is 2 meters per second. Hopefully you're seeing that it's 2 over that period of time. And our last velocity vector is only 1 meter per second. So let's compare these velocity vectors. I have a velocity vector of, there's v1, there's v2. And you can see that between those two, just like we had earlier, there is a change. Something has to happen there to turn it into that. We have to say v1 plus something is equal to v2. And not just something, v1 plus something times time is equal to v2. So rearranging this once more, we're going to say that our question mark is again equal to some difference in the first two vectors over time. And this is specifically called our acceleration vector. Acceleration is the change in the velocity vector over time. If I wanted to draw it in graphically, if this is v1, then this has to be our acceleration vector in order to give us our final, our new velocity vector. And so I can add that to my picture here. I can say, oh, you know what? I had an acceleration vector 1 unit long right there, and it's actually in the negative direction, and it's meters per second per second. So we can combine all of this information together to really pull a lot of stuff out of a motion diagram. It gives us positions at different moments in time. It gives us velocities between those moments in time. And we can even figure out the accelerations between each velocity moment shown. This is a very powerful tool. And tomorrow, when you watch the next set of videos, we're going to be doing motion graphs that are going to pull directly from these motion diagrams.